Okay, guys, we are going to talk about Chapter 11, Section 6. It's called Inverse Variation. So today you're going to be learning about this term, inverse variation. Fill that blank in. There should be a period here. The equation for inverse variation is y equals, not y equals mx plus b, but y equals k divided by x. K is called the constant of variation. As one thing goes up, something else goes down. That's what inverse variation means. Like, for example, how many days pregnant I am, and my level of patience. That was supposed to be funny, so hopefully you laughed. The more pregnant I get, the less patience I tend to have. And if the directions say to make an equation, here's how you're going to do it. You're going to put your info into the equation y equals k over x. You will probably be filling in for y and for x because you're going to have to solve for k. P.S. To solve for k, you need to multiply by whatever x is. And number 3, you're going to make your general equation just by putting k back into your equation. So for example, your equation might look like this. Y equals 3 over x. And that is an inverse variation equation. Keep going. Which one of these would not be inverse variation? Well, this one is good. That one is inverse variation. See how it's y equals a number over x? That's perfect. Now this one's really kind of sneaky if you ask me. If you were to divide both sides by 3 here, this last one, you would have x over 3 equals y. Well, that is not inverse variation because those two would need to be switched around. So that one is not inverse variation. Now this one right here, if you divide each side by x, do you see how like you would get y, these x's cancel? And you would get y equals 3 over x. That one is inverse variation. And this one doesn't have an x, so we're just going to get rid of it. It has to have an x to have inverse variation. Problem 1, we're going to make an equation for this. It says, suppose y varies inversely with x. Just this sentence, can you please circle it? I'm going to give you a moment to catch up. We're going to watch what that means right away. Y varies inversely with x. You can automatically know that's your equation you're going to use. Now we'll fill it in. Draw another arrow. It says y is 12, so we're going to take away that y and make it 12. It does not tell us what k is, but it does tell us that x is 6. So we need to figure out what is the value of k. Well, if you look at the steps I have up here, we plugged our info in. Now it's time to solve for k. All right, now what we're going to do is we need to get rid of the 6. So I want you to multiply both sides by 6. This is just your basic algebra skills. So 12 times 6 is 72. So we get 72 equals k. Now it says, what is the equation of the inverse variation? Here's the final answer. Y equals 72 over x. So if you plugged in x, you would get out y. So if you plugged in 6, you would get out 12. Let's try that again. All right, you can see in this problem, it says y varies inversely with x. That means you should write y equals k over x. Now we plug our information in. Y is 9. We do not know what k is, the constant. We do not know what the constant of variation is, but we do know x is 6. Multiply each side by 6, just like we did in the last problem. Oh, that doesn't cross off. That was silly. The 6's cross off, but not these ones. 9 times 6 is 54 for k. Why don't you label this so you know if it ever asks for it? This is called the constant of variation. If you need to pause the video, please do that to write that down. Now for our equation. You do y equals this number, 54, divided by x. And that is the answer they want us to get. Problem 2. Suppose you have a 200-pound weight and it's placed on a lever. And it is 8, everybody fill that in, 8 feet away from the fulcrum, which just means like the balancing point. Think about a seesaw. How far from the fulcrum should we put a 160-pound weight? So they're asking us, like, if we know we can almost pretend we have people on a seesaw. If you have a 200-pound person 8 feet away and a 160-pound person, where should the 160-pound person sit? Now, I hope you know, like, think about a seesaw. The lighter person always has to sit further away from the middle of the seesaw if you want to balance perfectly. This is inverse variation. As the weight goes up, the distance has to go down, and vice versa. So here's how we set this up. We're at y equals k over x, because as one goes up, one goes down. Let's let our 200 be our y. Let's let 8 be our x. Okay, so we're going to do 200 for your y value equals k, our constant, over 8, our x. Multiply each side by 8, just like we did in the last problem. That's 1,600 equals k. Now let's make our equation. So we get y equals this 1,600 over x. Remember, y is pounds, x is feet. So now we just have to plug 160 in and solve for the missing feet. So 160 is a pound, so it goes in for y. This time, x is unknown. So we're still going to multiply both sides by x. So we get 160x equals 1,600. We had to multiply by x to get rid of x. Divide each side by 160. And we get x equals 10 feet. By the way, you could have switched x and y. You could have done distance for y and pounds for x, and you would have got the same answer at the end. Just remember, when x is on the bottom, multiply it on both sides, and it joins the 160. That's where I got my 160x. And then I divide by my 160 to get my final answer of 10. Let's try it again. This time we have a 120-pound weight, and it's 5 feet. So let's set this up. Y equals k over x. I'm just going to do it the exact same way I just did my last one. I'm going to do pounds and feet. So I'm going to plug in what I know. So 120 goes in for y. We do not know k. And x is how many feet we put that weight. Multiply both sides by 5 because that was how far away we put that weight. 120 times 5 is 600 for k. Now we make our equation, just like we have in the past 3 problems. So we do y equals that 600 over x. My daughter just got home, so I'm rushing to get this problem done, hopefully not too fast. Now we're going to put an 80-pound person or an 80-pound weight on the other side of our seesaw, and we need to know where should we put that so we have a perfect balance. So this is a pound, right? So it actually goes in for y. So I do 80 equals 600 over x. I don't like where x is. I'm going to multiply by x on both sides. So the x goes away over here. And this becomes 80x equals 600. Divide by 80. X is, let's see, 600 divided by 8. A perfect 75 feet.